weather data for New York City here, where I have temperature, wind speed, and events based on specific days. Okay, and as you can notice, I have some spatial values here, minus 99999. Now what this spatial value means is the data is missing, but it happens to be that instead of these values being blank, they are these spatial values. Okay, and this will happen a lot when you're downloading data from internet or whatever is your source. You will notice these spatial values, and while doing data analytics you have to deal with them. Okay, so we'll see how we can handle these. Now first thing we are going to do is launch a Jupyter notebook. I'm going to use Jupyter notebook to write my code. You can use PyCharm or whatever IDE is of your choice. Okay, and I'm going to start my new notebook here, and as usual the first thing is to import Pandas module. I'm also going to use NumPy module here, and then you read your data frame using a read CSV method, and the name of our CSV is weatherdata.csv, and you print your data frame here. So this is how it looks. It created it successfully. Now I want to, let's say, replace all these values with NaN. Okay, not a value. So how you do that? You can just say df.replace. So replace is the method that we are going to use, and this method takes two parameters: the value that you want to replace. So here I want to replace minus 99999 with np.nan. Okay, and when you print your new data frame, it looks like this. So you can see that I now have NaN in place of this spatial value. Okay, so this looks good, but what happens if I have two spatial values? So instead of that, I have now in addition to 5 nines, I have 5 8s also. Okay, so when you read this, it looks like this. Now in order to handle it, you can just, instead of supplying single value, you can supply a list here. So it is pretty convenient. You can just say replace these two values with np.nan, and you can see that it replaced these 5 8s with nan. So this works great. Okay, but one of the things that you might have noticed is here there is no event. Well, the better example is actually 0. So let's say if you had 0 here, and I'll tell you why 0 is better than no event. Okay, so let's say if you have 0 here. Now to replace 0, so I can say, okay, replace minus 999, 8 and 0 with nan. Okay, so I can just simply add 0 and it will work, but it will be wrong to do so, because this replace is going through all the columns and replacing the values. Now 0 in wind speed is a valid value, so you don't want to replace 0 in wind speed column. So here what you want to do essentially is replace values based on specific column. Okay, so okay, let me first restore it back to original state, and let me read this again. This is how my data frame looks, and now what I want to do is replace values based on specific column. So you can do that by providing a dictionary here. Now what this dictionary contains is a name of the column and the value that you want to replace in that column. So in wind speed and temperature column, I have this spatial value that I want to replace, but in event column I want to replace 0. Okay, so when you execute this, you will see that now your data frame looks much better. Okay, all these spatial values are replaced with NaN, and then the 0 value in the event column is replaced with NaN. Okay, so this is how you can do replacement based on columns instead of doing just a generic replacement. You can also provide a simple mapping where, for example, now let me put no event back here. So let's say I have no event here, no event here. And now essentially in this data frame, what I want to do is replace this value with NaN and this value with NaN, okay? Or let's say I want to replace this value with sunny. So I want to assume that whenever I don't have any event data, the weather was sunny. And whenever I didn't have any temperature or wind speed data, I want to have np.nan. So for doing this, you will do new df equal to df.replace. And in this replace, you can provide a simple dictionary. Now this dictionary is just a mapping of value that you want to replace with. So I want to replace 5 nines with np.nan and also no event with sunny. Okay, so first let me just read this. My data frame looks like this. I have no event in event column and I have this spatial value in remaining 2 columns. And when I execute this code, you will see that I had no event at these 2 places and now I have sunny there, right, because of this. And this is same as the previous few calls that we saw. Okay, so this is how you can provide a mapping of what you want to replace with the new values. All right, now let's look at one more interesting scenario. Let's say this data had a unit of measure also. So instead of this being just 32, let's say this is 32 Fahrenheit. So a data provider put a unit of measure here, okay, and wind speed is usually miles per hour. So let's say I had miles per hour here, and my data now looks like this. So when you read a data frame here, my data frame is something like this. Okay, now this is a little bit challenging to deal with. What you want to do here is you want to replace all these unit of measures with a blank value. You want to just chop off miles per hour from these values and Fahrenheit and centigrade from temperature column. The best way to handle this would be to use a regex. A regex means regular expression. If you're not familiar with a regular expression, then I would highly encourage you to take a regex tutorial. So you can just take a simple regex tutorial and kind of gain an understanding on how regular expressions work. But just to give you an idea, they are used to detect patterns, okay? And whenever you want to replace patterns with some other value, that's when you use regex, okay? Now here I'm going to again say df.replace. Okay, now my first argument will be the regular expression. So the regular expression is something like this. Wherever I see a non-digit character, a character between, let's say, A to Z, I want to replace that with blank. In regex, the way you do it is by saying capital A to capital Z. This means any character between capital A to capital Z, and also any character between small a to small z. Okay, I want to replace that with a blank value. And if you just do this, it's not gonna work. So you have to say regex equal to true. Let's see what happens. Okay, now you see that it removed miles per hour from these 2 guys and Fahrenheit and centigrade from here. So that part worked, but it erased entire event column. Why? Because everything in the event column is alphabet. It's a non-digit character. Okay, so really you want to do it based on column. You don't want to touch this particular column. So what I will do is I will use dictionary. So let's say I remove this. So you will use dictionary and you will say temperature column, anything that is a alphabet. Okay, wind speed column, same thing. Replace that with this blank value. Now when you execute this, you will see that your data is in a much better shape, where you have removed all these unit of measures and your event column is also now intact. Cool. Now the last thing we want to cover is how you can replace a list of values with another list of values. Now for this, I'm going to construct a different data frame. The data frame here looks like this. In this data frame, I have student name and their score. So for example, Rob, Maya, Parthiv, Julian, all these are the students studying in specific class. And let's say they scored this much. Okay, so Rob's score is exceptional, average, good, poor, and so on. Okay, now whenever you are doing data processing, you often want to have numbers in the score column. So for example, internally, let's say I have a mapping of all these scores to some number. So for example, poor will be like 0 or 1, and this will be 2, 3, 4, and so on. Okay, so whenever in the next stage of processing, now I want to replace these guys with numbers. So to do that, you will simply supply first list here, and the second list will be the values that you want to map these individual values. So here what I'm saying is poor is really 1, average is 2, and exceptional is 4. Okay, so do this. Now when you execute this, you will notice that now your new data frame has these numbers as a score. This could be pretty powerful, and while doing data analytics, you will end up using this for sure. Okay, that's all I had for our replace tutorial. In the next tutorial, we are going to cover how you can do group by. So group by is also an important concept in Pandas. So stay tuned, and